Equally likely outcomes. A flight has been overbooked. However, there are two seats available, one in business class and one in first class. The ground crew decides to upgrade two of the coach regular class passengers so that two more passengers will be able to get on the flight. The crew has identified five passengers, two males and three females, who are traveling by themselves and who have been loyal frequent flyer on the airline. They decide to choose two of those passengers as random for the upgrade. The first chosen will be upgraded to first class and the second chosen will be upgraded to business class. Denotes the two males and three females with M1, M2, F1, F2, and F3. Before we move on, observe that the order that we list matter because the first chosen will be upgraded to the first class and the second will be upgraded to the business class, though two classes are not the same. It is a huge difference whether we get the first class seat or the business class seat. Part A. What is the sample space in this case? Recall that the sample space lists all of the possible outcomes. We first assume that male M1 is chosen to be upgraded to first class. Then one possible outcome is M1, M2. The two male passengers are chosen. M1, F1, first male, first female. M1, F2, M1, F3. These are the possible outcomes if the first male is chosen to be upgraded. What about the second male is chosen to be upgraded? Then we would have M2, M1 as one possible outcome, M2, F1, M2, F2, M2, F3. What happens if the first female is chosen to be upgraded to the first class? There would be four similar possible outcomes: F1, M1, F1, M2, F1, F2. We can't have F1, 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 F3. And in this case, we will list them all: F2, M1, F2, M2, F2, F1, F2, F3, F3, M1, F3, M2, F3, F1, and F3, F2. There are a total of 4 by 5, which is 20 possible outcomes, and we list them all in the sample space S. Find the probability that the two chosen will be of the same gender. We will denote this as P, open the parentheses. The event is that the two chosen will be of the same gender. So we will abbreviate this as the probability of same gender. This is the case when both males are chosen or both female are chosen. We have M1, M2, both males, M2, M1, both males, F1, F2, F1, F3, F2, F1, F2, F3, F3, F1, and F3, F2, both females. Again, F3, F2 is not the same as F2, F3. F2, F3 meaning the second female will be upgraded to first class, while the third female was upgraded to the business class, but F3, F2 represent the case where the third female is upgraded to the first class and the second female, in that order, is upgraded to business class. There are a total of 1, 2, 3, 4, 5, 6, 7, 8. And so the probability of getting the same gender is 8 out of the total of possible outcomes is 20. Simplifying this, we have 2 over 5, but 2 over 5 is 0.4. Precisely 0.4. Part B. Find the probability that the two chosen will not be of the same gender. We would count the outcomes that have both males and female. This is M1, F1, M1, F2, M1, F3, M2, F1, M2, F2, M2, F3, F1, M1, F1, M2, F2, M1, F2, M2, F3, M1, F3, M2. There are a total of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Pretty much everything that is remained from the previous case. And so the probability that the two chosen will not be of the same gender, we counted, there were 12, divided by the total of possible outcomes in the sample space is 20. This is 3 over 5, or precisely 0.6. Compare the two previous probabilities. Are the two events equally likely? Clearly, one has a probability of 0.4, the other one has a probability of 0.6, so the two events are not equally likely. And we see that from the result, it is more likely to select two passengers that are not of the same gender. This is more likely because the probability of not getting the same gender is 0.6, which is higher than the probability of getting two passengers of the same gender. And again, they are not equally likely because they do not have the same probability.